Alrighty, folks. Let's get started here. Looks like we might have some folks kind of trickling in here. But can everybody hear me right now? I've got a new setup. It's all right? Okay, good. Well, let's get started. Right? This lesson tends to take a little bit less time, but that's what I said last time, right? So, and then we went overtime. So, I'm not gonna jinx myself this time, but you know, the principles in this workshop, right? This specific lesson, 1D and 2D rotations, are going to directly apply to the spatial visualization test that we took at the very beginning of the semester. And so, you know, if you plan on taking the test again, right, then, you know, this will be great practice. This will be a good work for that. If not, then that's fine, right? It's still good practice because this isn't necessarily the most intuitive skill for us to use. So let's dive into it. First things first is I want you all to open up those, hello? I want you all to open up that annotation tool, okay? Up in the view options where I'm sharing my screen, you should be able to click on annotate and go ahead and draw something on my screen, right? Anything on my screen that is appropriate. I am recording this video after all. But go ahead whenever you come across it, right? Go ahead and start drawing on my slides, right? This is going to be an interactive thing, and yeah, it'll be a lot of fun if we can do this all together, right? So 5 more seconds of getting it out of your system until we start talking here, and we'll get going here now. Okay, so, all right. We have a familiar shape, right? Specifically, you know, this kind of stair-step shape that we've used in previous workshops, right? And today what we're going to focus on is, again, rotating this shape along multiple axes. Multiple could be 1, multiple could be 2, right? But what does that mean exactly? Well, to start us off, the first thing that we always do, no matter what, in every single spatial visualization lesson is what? We already have it done up here, but what do we do every single time? What do we start with?
The axes.
Axes, right? We have a coordinate system. Very good. So we have our coordinate system ready, rearing to go. All we need to do is use it. So let's talk about this. If we were to say, let's rotate our shape around the x-axis, which direction do you suppose I mean when I say the positive x direction? Right? And let's just keep it simple. Let's say 90 degrees in the positive x direction. What do you suppose I mean by that? Which direction is that? What do you think? I'll also invite you to turn on all of your cameras and also unmute yourselves, assuming that you're not in the middle of a shopping mall full of people. It shouldn't be an issue. What do you think? What does positive 90-degree rotation mean? Maybe you can draw it on my screen, right? Then it's anonymous, right? What do you think it means? Okay, very good. So that direction, right? The direction of the arrow, and that's fantastic, right? So let me see. There we go. So kind of, at least in the slides right here, what we've drawn is kind of counterclockwise, right? Why counterclockwise? Any reason? Any particular reason why you chose to draw it in that direction? Maybe you know the answer. But why clockwise or counterclockwise? Well, I guess it's probably arbitrary, right? But let's think about this, right? When we talk about clockwise and counterclockwise, right? Let's say that I'm using this as my arrow. Let me get a pen out of this basket, right? So this pen is my arrow. And let's say that I have it pointed directly at you. Right? Rotating around this shape in a clockwise direction to you, right? Would you all agree that the way that I'm rotating around this axis is clockwise? Right? But to me, let's see if I can do this. It's like rubbing my head and patting my stomach at the same time, right? There we go. Cool. Now what direction is it? It's counterclockwise, right? So this idea of clockwise or counterclockwise really breaks down depending on who's looking or which way you're looking at this thing. So it's not really an appropriate way to say, you know, positive X direction means that you're counterclockwise or clockwise. We need a more rigorous definition of this, okay? And so let's do that. So if we move on to our next slide, our next animation, I want to show you something called the right-hand rule. Now, the right-hand rule is something that we will see in physics, right? We'll see it in calculus. Has anybody actually seen the right-hand rule before? Yes? Okay. Some of us, that's fine, right? But effectively, the rule is very simple. Right? The right-hand rule says that you have a vector, right? Some arrow pointing out, say it's the x-axis, the y-axis, whatever, right? It's an arrow. The first thing that we do is we need to put our thumb, align our thumb, our right thumb, along the vector's axis, right? So everybody put your right hand up. I'm not going to make you swear on a Bible or anything like that. What I'm going to have you do is kind of contort your body and line your thumb up so that it's facing along this x-axis, this yellow axis in the screen, right? And you kind of have to wiggle your way around, right? But it's kind of pointing to the right and out of the screen, just a little bit, right? And down maybe a little bit too. When we do that, when we align our thumb so that it's pointing in the same direction as this yellow x-axis, the positive direction of rotation is defined by the way that your fingers curl around that axis, right? Now, you'll notice that if you do this with your left hand, you get the opposite direction, right? This is not called the left-hand rule. This is called the right-hand rule, right? For a reason. Because your right hand's fingers will curl around this axis in what is defined as the positive direction, right? It just so happens to be the case, but this is a law of nature, right? You're going to see this rule a lot in your future classes, right? Especially the ones related to physics, right? And that's it, right? That's the trick. So when we're defining these rotations, if I were to say, let's do a positive X rotation, how would you describe, that rotation? Well, actually, two of you had already written that rule accurately on the screen before. I had erased it because we had gotten a little bit ahead, right? Spoiler alert. But now that we see it, right, our rotation would be like this, right? We would go from this line, right, erected up parallel to the y-axis, and we would flop it down such that it's now parallel to the z-axis, right? So if we were to look at this, right, a little bit more closely, that's what it would look like, right? We flop this thing down. We can think of that movement as kind of like a flag along a flagpole, right? If we string this shape up such that it's linked like a flag on a flagpole to the x-axis, we're hinging it across and down that x-axis in the positive direction defined by the right-hand rule. So somebody tell me, right, what would the negative rotation look like? How would you describe it? Okay, I see Dongyu using his right hand, right? His thumb and our thumbs, right? Everybody put your hand up, right? This is the reward for showing up for Spatial Viz this week, right? You get to look kind of foolish with your hand all contorted, right? So put your finger along the x-axis but backwards, right? So pointing the opposite direction, and the curl of our fingers around that axis like this dictates the rotation, right? I love this rule. I love this class, mostly because when I get to do the test in person, right, in class, it's hilarious and really heartwarming to see. You know, the first time I see folks doing this test, it's like, okay, they're, you know, people are trying to figure this out in their head. They're like rotating it as what is going on. The second time I do it, the retest that we get to do this week, I see people doing this. They're doing this and they're twisting around and they're contorting and they're, you know, doing their rotations, right? Because the right hand rule changes everything. We get this definition for how we do this. And literally what we need to do in every single problem is define which direction we're spinning, how much we're spinning, and just write it down, right? It's like a little recipe, right? And that's really all we need to do, okay? So this first thing, right, the right hand rule, that's the biggest ingredient in this, you know, this recipe. The second thing, that the tips that I want to show you right here are, number one, we are only doing this in 90-degree increments, right? So 90, 180, 270. What is the same as positive 270? What's the same? What's the same as?
Negative 90.
Negative 90. Okay, good. So thank you, Brendan. Right, so negative 90 degrees, same as 180 degrees. Okay, and then this flag around the flagpole idea, right? Keeping this shape hinged on a specific axis as we rotate it around. Okay? So let's practice this, right? And I'm not going to draw this at all, right? I want you all to use your annotation tools, right? Use the pencil tools to answer these two problems with me, okay? So the first one on the left is we need to identify the amount and the direction or axis that we are rotating around. Let me erase my old annotations. Here we go. So if the first shape, right, this is our primary shape. This is the one that we're starting with. Up here is our first shape here, right? In this problem, how do we answer these two? How do we fill in these two blanks? Somebody help me out and start either shouting it out or draw it with the annotation tool, right? Let's see what we think. Right? So using the right hand rule, we can see that this thing is kind of flipped upside down, right? We might see that the bottom of this shape is now on the top, right, of this axis, right? So what is the correct rotation combination? Maybe it's just the first amount that you fill in, right? Or maybe it's the direction. What do you think? If this shape rotates to here, what amount does it need to rotate? Again, so this bottom face, right, is what's up here now. Right? What do you think? Somebody take a stab at it.
I feel like this is really wrong. Is it 180 degrees across the z-axis?
The z-axis? Jacob, you could not be more wrong about being wrong. You are totally correct, 100%, right? Fantastic, thank you so much, right? If we rotate this thing like this, 180 degrees around this z-axis, right? Then this shape, right? This bottom shape becomes, or this bottom edge becomes this bottom edge, right? And that would be, so yes, 180 degrees in the z-axis. And really, in this case, plus or minus doesn't really matter, right? Because 180 degrees plus is the same as 180 degrees minus. Awesome. Thank you so much, Jacob. That was perfect, right? Very good. So now, how about this? This is a different rotation, right? And so this is more of practicing drawing, right? Does somebody want to help me by starting to draw what the end result of this shape rotating negative 90 degrees along the y-axis should look like? This is challenging, right? But go ahead and somebody grab their pen tool and start this off, right? I'm gonna draw this right here. Maybe get my eraser and erase this guy. These. Okay, what do y'all think? Let's see. So if we rotate 180 degrees in the negative y direction, right, that vertical blue axis, right? Everybody put your hand up, right? How does it rotate? Well, so negative 90 degrees would mean my thumb points down, right? And it rotates like this around this axis, right? Something like that. 90 degrees. So what would that look like? Maybe you describe it in words, right? What is, if let's see, if the z-axis, if this is the front, and then this is the right side, and this is the top, right? What is the new right side? Describe it, or the front side. I see somebody starting to draw. Go for it. Wonderful. Thank you for drawing, whoever you are. Red pen. Okay, sweet. I love it, right? So we have this L shape, this backwards L shape that is now kind of swung around, right? That's this back side that was hidden from us earlier, right? Okay, perfect. And now we're drawing this edge, right? And this face has swung across here. So now it's on the front side instead of the right, right? Very good. Finishing out the top face right here. So that's this and that's this, right? We're almost there. We need to take into account this top face right here. Looking good. I'm going to start cleaning up this space a little bit so that it's not so messy from all of my annotations. We just drew, let's see, this edge and this edge, right? No, that was good. Somebody erased it, but they drew it back up there, right? Nice, okay, so we have that. Unfortunately, I made a poor choice in my grid, right? I didn't quite give you enough room. My apologies there, right? But yes, we are looking good. We need to draw this edge, right? And I would argue that, can anybody identify an edge that was drawn recently that may not be an appropriate edge to draw? Ah, very good. It disappeared magically, right? Thank you. But it was drawn here, but there's no edge there, right? So this face needs to be continuous. Here we go. Beautiful, 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 beautiful. That is the correct answer, right? So arguably this exercise, right? This drawing, this shape having been rotated, right? This isn't the thing that you're being tested on in the spatial visualization test, right? You're just being asked which one matches with which, right? But really, you know, all of these tools kind of go together. And again, that's why I'm giving you extra credit for this if you go through this entire workshop, right? This is an entirely new skill, being able to draw things like this, right? So we are learning extra skills in addition to the fact that we will now be able to have a strategy when we get into the spatial visualization test again, right? So wonderful. Thank you for doing that. Does anybody have any questions before I move on? While I move on, I'm going to clear my drawings here real quick. 3, 2, 1, any questions? Of course not. We're all hungry. Hopefully you all ate. I'll be very disappointed if you did not feed your brains before you showed up here. Please feed yourselves before you show up. All right. Now, on to the next one. 1 degree rotations, 1 axis rotations. All right, we figured that one out. Straightforward enough in terms of the rules. Putting it in practice is a little bit challenging, but let's ramp it up just a little bit, right? And by a little bit, okay, I do mean a lot, right? Because this is when the test gets really tough. 2 axis rotations. Let's talk about this, right? For our tips, all of our tips from the 1 axis rotations hold true, right? Still using the right hand rule, still using this 90-degree increment rotation restriction, right? And the flag around the flagpole still kind of works, right? You just have to restring your flag. If you rotate it around the X, you have to take it off the X flagpole and then put it on the Y flagpole later, right? Or something like that. But there is a bit of an issue that we run into. Rotations are not commutative. What in the world kind of words am I making up, Mo? What are you trying to pull? Well, let me give you an example and ask somebody to finish this problem for me. It's going to be a tough one, but I think that you might be able to figure it out. Somebody draw it up there. What is the answer to this very difficult college level math question? There we go. 7. Very good. I love it. Now, all right. 9. All right. Now let's really ramp it up here, okay? Ready? What's this one? If that's 7, what is this problem? 7, right? Okay, yeah, I won't belabor this task too much, right? There's 5 plus 2 is the same as 2 plus 5, right? This addition is an operation that is quote unquote commutative, right? We can commute these two numbers back and forth, and it doesn't matter which direction, which order they're in, the answer is still the same. Now, don't tell your math professor that I'm about to say this as an example of things that are not commutative, because they will be angry at me. But for a rough example, let's say this. Oh, wait, what am I doing? I'm already messing up. 5 minus 2 is, somebody fill that in for me. 3, very good. And 2 minus 5, maybe you get there before I even finish. -3, right? Okay, so this is to say that the order very much does matter when we're doing something like subtraction. Again, don't tell your math professor this isn't quite rigorous, but it's a simple example, right? The order matters. And in the same way, rotations matter. The order in which we do a rotation matters, right? So let's use an example, right? If we were to do, and let's just pretend that these are 90-degree increments, right? If we were to do a 90-degree rotation in the x direction, followed by a negative 90-degree rotation in the z direction, what does that look like? Well, everybody kind of imagine it in your head. I'm going to start drawing this on the slides, right? So we don't need to do any drawing quite yet, right? But it's going to, everybody put your fingers up, right? It's going to curl around the x-axis. It's going to lay down first, right? It's going to kind of swing around there. And then from here, it's going to swing around the z-axis, but backwards, right? The negative z-axis. So it's going to swing kind of down and to the left, right? So it goes, it flops down to be flat, where its back was now on the top, and then it swings down to be under here, right? Okay, straightforward enough, right? At least when we see it done for us, right? But how about let's do it backwards? What does it look like when we first do a negative z rotation, right? It's going to flop forward, right? Such that that kind of backwards L shape in the left-hand side is now on the top. And then we do a positive x rotation, right? This thing is not the same orientation, even though we did the same 2 steps, right? The order matters when we talk about rotations. This can be very confusing when we're talking about actually defining these rotations. The saving grace here is the fact that in the test, we don't really care how you got there, right? It's not asking you, did you do a 90-degree rotation in the x direction followed by a whatever degree rotation in the y, right? It's just asking you to match shapes. But our recipe that we're following, our strategy that leads us to that correct answer, that is where things get a little bit confusing, right? The additional interesting thing, right, is let's use this Combination of shapes real quick to make this example, right? If this is our end goal right here, right? If this one's our end goal and we're just going to get rid of everything else in here just so we're not distracted, right? Get rid of this guy, get rid of this guy, right? If our shape, if we got here by going from, let's see, we did a positive x, right? Positive x rotation followed by a negative z rotation, right? Both of these are 90 degrees. What is another way that we could get from here to here? The thing is that there's more than one way to get to a 2-axis rotation, right? And what, does anybody have any other ideas on how they could get there that's not positive x followed by negative z? Does anybody see any other ways to get there?
Could you do negative z and then negative y?
Okay, so negative z means that we would flop it back on its back, right? And so that means that the kind of this staircase, right, flips up backwards, right? And then we need to do a positive y rotation, right? So it's a little bit difficult to see when I don't have animations behind this, but yes, I will grant you yes. Let's just get this up here, right? A positive 90 z rotation followed by a positive 90 y rotation gives us the same answer, right? So when you're doing the exercises in the homework exercise sheet, right? If you're doing the workbook exercises, right, it's going to have you doing these, you know, x followed by negative y rotation kind of answers, right? You'll notice that, you know, it only gives you one answer. If you chose something different, then it still doesn't mean that you're wrong, right? So it's a little bit challenging, but keep that in mind, right? There's more than one answer to these problems, right? So again, does anybody want to see a little bit more about how this works, or are we kind of all in agreement that positive x followed by negative z is the same as positive z followed by positive y? And did I translate that correctly? So the shifting around these axes is a little bit challenging too, but yeah. So positive z, it rotates up, and then we rotate it around such that that staircase is kind of upside down, right? All good? Okay. So let's, did I do that right? No. Ah, see? This is why you speak up.
Y?
It should be a negative z. Is it right? Do we see that? It should be a negative z, I believe. Let's confirm that. Can anybody confirm or deny the fact that I did this totally wrong and it should be a negative z? Does that make more sense, or am I still wrong? I'm here trying to talk and math at the same time. Let's see. So a negative z would flop down. Okay, that makes more sense, right? A negative z would expose this L shape to the top, right? This L shape would be kind of in this direction, right? And the staircase would look like this. And then when we rotate it around the y-axis in the negative direction, again, see, I'm double wrong. This is why. This workshop should make you feel extra smart, because any workshop with me is guaranteed to be full of flaws. No, I swear I know what I'm doing. It results in this kind of stair step like this, right? So negative z rotation, which flops it down, and then a negative y rotation gets it around that axis, right? Okay. Are we now in agreement? Don't agree with me just because I'm the instructor, right? Goodness knows that'll get us all in trouble. Okay, so let's keep going on this. So somebody help me out. We can start drawing, or we can start writing down our answer right here. Let's practice this together, okay? Let's just go hog wild with this thing, okay? So I'm actually going to, I'm not going to focus on this one, right? If you start drawing in some answers right here, that's fantastic. I'm going to start kind of talking through this one, but I'm not going to draw it, right? So let's see. A negative y rotation, right? First means that we start by going, let's see, our thumb goes down, and so that rotation looks like this. It looks like somebody's already starting to draw, which is fantastic. And then we need to do 180 degrees around the z-axis, right? So ultimately, let's see, this bottom shape, this bottom edge is going to be up on the top, right? This bottom square. And what's going to be on the left and right? Let's see. When we rotate our y-axis, this L shape is going to be, it's going to move over here to the left. But then we're going to rotate it down. So it's going to look like this, right? So our L shape is going to be like this. Right? So let's start with that, right? Looks like somebody's already got the base. That's fantastic. Wonderful. Let's keep pushing through this, right? So looks like, yeah. And I'm going to do this just for the sake of making some space, right? So I'm going to move this shape up here, right, just so that we have a little bit more space. And then we can move on from there, okay? So go ahead and start drawing, right? Again, this L shape is going to be on the left, right? We noticed that from that intermediate step. When we rotate our y-axis negative 90 degrees, this L is going to move over here, right, to this shape. And then when we flip it around upside down, it's going to move to this position, right? And it flips along that red axis, right? So that's beautiful. Good, good, good. I'm going to start tracing over our shape just so that we can solidify when we get the right answer. Okay, so we got this, we got this, we got this. What else? What other edges do we need to draw? So let's see, let's start making this a little bit more clear, right? So we've drawn, don't be shy, come along, let's do it. Right? So here's, this edge has been drawn, right? And these edges have been drawn. Looks like somebody's using a highlighter, that's fine, right? Okay, here we go. They figured it out. Okay, so we've got this vertical edge. Let's see, where is that edge? We are talking about the edge behind this that's along the y-axis, right? That's what this edge is. Is that correct? Well, not quite, right? That's not what we want to do quite yet, right? So this edge along, let's see, if this edge is this edge, right? Ah, there we go. So now we're drawing this, right? So I'm going to keep kind of translating it over here. Good. Beautiful. So we have drawn this, right, up here. I would argue that this yellow line is a little too long, right? So we're going to do this edge to complete this edge. Right? Okay, very good. Is there anything else that we need to worry about? Let's see. I think that this face is going to be visible. Is that right? Yeah. So the edge that kind of comes along here, where does that edge go? This kind of edge that goes along here. Where does that one go? It starts in this corner, which is in this corner, right? Where is that one facing? What do y'all think? Ah, very good. Very good. So we drew that edge, and I think that it could be a little bit longer, right? Because it's 2 blocks long. I drew it a little bit too long in this one, right? So somebody go ahead and draw that. Beautiful. And so the last thing that we have, let's see, is, let's see, did we draw this correct? How did we, where did we, so from that corner, that inside corner, we go into edges, and I think that that's it, right? So yeah, okay. It's a little bit of a confusing shape, right? Because we actually have 2 levels, right? Kind of shifted on top of each other. But are we in agreement that this shape is drawn correctly at this point? Does this feel good to you? I think it looks good to me, even though it's a confusing looking shape, right? This front edge, right? This edge right here is kind of going like this. It goes in, it interlocks with this face. Right? Okay. So it's confusing, right? It's hard to see, but again, I think you'll recall back to the test that there were some confusing looking shapes, right? So let's finish this up with these answers, right? What is one way to get from here to here? Again, there's multiple answers, right? So let's take a stab at it. How do we get from here to here? What do you think? 90. Okay, good. 90 degrees what? 90 degrees what? In the z-axis. Okay, so that would be putting our thumb along the z-axis and flipping it back. Okay, and then what? So I would say that we're really close to a correct answer in that first 90 degrees thing, right? In the 90 degrees z. I would say, is that a y or an x? Okay, looks like, and then a negative 90 in the y. Okay, good. So positive z direction rotation, right? Let's see that. Right? A positive z rotation would flip this thing back, right? Actually, wait, am I thinking backwards? Let's see. Yes, I was going backwards. I was going this way. So let's see. Positive 90 degree z-axis rotation would flop this back such that the L shape, like this, would be facing on top. And this L would be now facing kind of like this, right? And then when we do a rotation for that, let's see, positive y now, we've decided, right? That swings us around this way, right? Around this y-axis, which means, yes, now this L shape is facing forward just like this, and our smaller L shape is facing out like that. Very good. Okay, so we're in good shape. Beautiful. So a positive 90z followed by a positive 90y is a rotational option, right? A rotation combination option. Very good. Okay, so if you didn't participate there, no sweat, right? You have an exercise sheet this week. Go ahead and try it out, right? Practice, practice, practice. We have answer keys for those things that are in the workbook exercises, right? I really encourage you to do the workbook, even though the workbook is kind of a drag sometimes. It at least gives you some answers to compare to, right? So last thing that I want to show you are 2 tricks, right? Started off with the tips. Now we're going to move on to the tricks, right? The tricks that I have for axis rotations, right? And I would argue that this is probably one of the most helpful things in the entire workshop, right? So listen up, okay? We're going to do something called write a rule. The write a rule trick starts off by picking a side on your original shape, okay? So let's say that we start off with these top right and front sides, right? That's how all of these go. We're going to pick a side. I'm going to pick the right side, right? Then we need to find the same side after the rotation. So this side, somebody mark it with their annotation tool. Where does that side travel to when it's been rotated? Very good, right? So we rotate up to this top face, right? The rule that we write is called right to top, right? Right to top. This side moves from the right to the top, okay? And now we just do that for this next one, right? So the first side on the new object is right, on the right, right? That's our rule. The right-hand side, we now need to follow it to the top, right? Because that's what which of these 3 shapes follows that rule? Okay, so this first one is good. This one also follows that rule, right? You see that the L shape is on the top for both of these, right? So we have narrowed it down from 3 answers to 2 answers. And if we were in the real test, right, which has 5 options, we've really narrowed it down, right? So it's not an end-all be-all answer, right? But if we do it again for another side, we can figure it out definitively, right? So let's do that. So let's say that my next side is this face, right? Somebody did it already. Sure. Let's see. My front face moves where on my second one? There you go, right? The move. And so the rule is what? This one's a little bit, kind of seems silly, right? But what is the rule if we write a rule? The last time it was right to top. Now it's what? Somebody write it up there. Front, front. Okay, somebody wrote it. Good. To what? To the front, right? Front to front. So if the L shape like this moves to the front, well, hey, there it is, right? Front to front. That's easy. Right? In this one, that's not what happened, right? So it must be the case that this shape is our answer, right? We had to do it twice because our first attempt didn't narrow it down all the way. But this is a very easy way to pick out, to narrow down our options and identify shapes by their faces, right? The only trick is making sure that you pick a face that you can see at the very end, right? If we chose this top face, right, in this writer rule, right, where does the right face go? Well, it goes to the back, right? That's still a rule. We can do that, but it's just kind of like we can't see it afterwards, right? So that's kind of hard to do. I would stick with faces that we can see travel, right? Like the front going to the front and the right going to the top. Again, this will depend on which problem you're working on, right? All of them have different rotations, but keep this in mind, the write a rule trick. The second trick, let's see what's going on. Here we go. I call it the crab claw because this shape, which is the, again, spoiler alert, this is the starting shape for every problem on the test, right? It's in different configurations and it's in different orientations and it rotates in different ways, right? But this shape is the first shape in every problem on the test, all 30 of them, right? I think this looks like a crab claw. So why not use your hand to kind of use a proprioceptive, a kinesthetic, something that's attached to you, a very tangible way of saying, okay, if this moves like this, then a shape that looks like this is also going to move like this, right? This helps me a lot, right? The crab claw orientation trick is really helpful. The write a rule trick is really helpful, and the rotation naming rule is just kind of like the ipso facto definitive way of solving this problem. So let's review all of these tricks real quick, and then I'll let you go, okay? So for this trick, first things first, the crab claw, right? I would say that this one looks a little bit like a lazy boy sofa, right? This one looks like a crab claw, so let's use this method. Everybody hands up. I know it's silly. Don't let your roommates laugh at you if you're in your room, right? Pinch them with your crab claw if they do, right? Okay, the crab claw rotates like this, right? Oh, Nathan's eyeballing his roommate, right? Don't you dare, right? Okay, so the crab claw rotates like this, so therefore the sofa rotates like this, right? We get kind of a shape that we know just by the crab claw is going to look something like, you know, this this shape is going to move to something like, yeah, draw for it. Draw. Just because I'm drawing doesn't mean you can't draw, right? The shape is going to look much more square than that, but you get the idea, right? It's kind of, the sofa is facing to the left instead of to the right now. Right? Okay, whoa, what is that? I pressed Control Z too many times and everything went haywire. Okay, now the rotation naming, right? Let's name it. Well, I just showed you the answer, dang it. But what's the answer? Well, let's use our right-hand rule, right? Right-hand rule says that it's rotating in this direction, right? This is the opposite method, right? Before we were given a vector and we rotated around it. Now we can see the rotation. The rotation is like this. So the vector that we're going along, okay, that must be the negative z-axis, right? Let's name it. It's negative 90 degrees in the z-axis, right? Okay, last thing is the write a rule trick, right? If we start with the right side, where does the right side go? The right goes to the, somebody draw it up there. Front, very beautiful, wonderful, right? The right goes to the front. Okay, that's this face. Okay, and so the right hand side goes to the front. Right? So let's see. Did I give you an actual shape? What? Oh, okay, here we go. That's right, I gave you the option. So now we have all of our methods, whichever one's your favorite one, right? which one is the answer. Looks like somebody already started drawing on it. That was wonderful. Everybody draw a circle on there. Everybody draw it. Or you can use the stamp tool. The stamp tool is fun. It gives you little hearts and stuff, right? Please don't get me in trouble by having me show you this annotation tool and you start drawing all over your teacher's slides next time you're in class. Or at least if you do, don't tell them that I showed you how to do it, right? So, perfect, right? The letter D is our answer, right? Beautiful, wonderful. There's a question mark on there. Hopefully you're not confused. Hopefully this is just saying that we got it right. Wonderful, I love it. Everybody draw something and then we will close this out, okay? I'm only 1 minute over this time. Boom, nailed it. Right? All right, 5, 4, 3, 2, 1. Enough with the drawings. Oh, keep going. Right? Okay, so how do I keep on with my slides? Here we go. Okay, so things that you can expect this week from me, right? I have already posted the new assignment, right? Da-da-da. I've already posted that. So go ahead and go do it, right? Again, just like every week, I want you to spend an hour working on these exercises, right? Again, the workbook exercises, they're kind of a drag, right? They're kind of boring, but you have something to compare a correct answer to, right? So I do strongly encourage you to at least do a few of those, right? The CAD exercises as well, right? They have like those little exercises that have computer-aided design, right? They kind of just move the shapes around. That's pretty helpful. I'm going to post this lecture video here tonight too. And I am also going to open up tonight. Actually, I'll probably do it tomorrow because I know some of you and some of your classmates have tests this week, right? Does anybody have a test remaining today?
I have a midterm at 8.
Oh my goodness, Maya, you best of luck, right? All of you who have tests, you've got this, right? Please feed your brain, right? You have an hour. Don't cram, right? You've already done your studying, right? Go feed yourself, right? Take a walk around the building. I'm going to release you now, but tomorrow, I'm going to post the, I have already posted the practice exams, right? So you have a whole bunch of practice options that look just like the spatial visualization test. I am also going to post the spatial visualization retest. So if you want to retake the test and attempt to get a score higher than 20 out of 30, if you do that, you get 5% of your Gene 1400 grade, right? Even if you've already done that, just by being here, you're halfway through the workshop. You are halfway to 3% extra credit for your Gene 1400 grade, right? So congratulations, you're doing great. Go take that retest anytime in the next week, right? You have plenty of time. Go ahead and retake it. The highest score wins, right? And the highest of your scores wins. And keep in mind, right? I want you to do your assignments, right? Take a look at the practice test before you move on to the retest, and that's it, right? Do we have any questions for me before I let you go? How are you all feeling about your tests? No, wonderful. Good. How are y'all feeling about your tests? Everybody thumbs up, right? You got it, right? Good luck tonight, everybody, right? Email me if you need any help, right? If you want to talk about this, if you want to talk about anything else, bad. Oh no, we're gonna cover this up with hearts. Right? You're good. No, you're good, right? Only positive stamps on this slide, right? Check boxes and stars and stamps. Right? Okay. Go eat, go rest, and kill your test. Okay. Y'all rule, and thank you for being here. Okay. We'll see you later, and we'll see you next week. Okay.
Thank you, Mo.
Alrighty.
Thank
Bye.
you.
Thank you.
Thank you.
Thank you.
Thank you.